My name is Joshua Moffett. This is 20th of April of 2019. This is my final project for the Fasteners Lab. My student ID is JOMO07033 and the course is FTT 111D. What I have in front of me right now is some of the tools that came in from the school that coincide with the final project. So what I have here is what the school sent is the T-handle tap wrench, an extractor bit, the 3/64 ground center drill, the 5/64 jobber drill bit, the number 31 jobber drill bit, 3 fastener Phillips screws, and then 1 threaded tap bit. It also came in with a block of aluminum, digital caliper, a ball of permanent blue, and then I also have just in the house a marker. You can also use a liquid marker for the aluminum so you can see your scratch marks once you start applying and finding the center of your aluminum block. And then also a spring-loaded center punch to make pre-start for my holes. So let's finish off from here and we'll go ahead to the table. So what we're going to start off with is we're going to go ahead and take our marker. What we want to do is kind of go ahead and start making some marks on here, so once we start using our caliper to make our cross points, we can see it on the aluminum. So we'll let that dry real quick. So while we're waiting on that, what I went ahead and did is some calculations. So I measured the aluminum block from the tops to find the center point, and then the length. I went ahead and found the center point for the length of the total measurement, and then I divided it again to get the center points between that center hole and the end of the block of the aluminum. So with already having my math already complete, I can go ahead and take my dial, and we're going to go ahead and make our first scratch mark on the aluminum, going lengthwise here, which we got 1.0282. Caliper down so it doesn't move while we do this. Alright, we're just going to start here at the end. Just kind of controlling it. And just going ahead and making our scratch mark straight up here through here. Making sure it's visible that we can see it, which we can. Alright, so you can see the first line there. Alright, so now we're going to go ahead and do the other scratches, which is the first one's going to be at 2.0277. So we'll loosen this caliper up so we can adjust. Tighten it down. Alright, from here we're going to go ahead and do our center. Okay, and then we divide it 2 again because we need to know the center point between this center mark and the end of the aluminum block. So we'll loosen this up and then go down to 1.0138. Alright, so we're going to go from here to the end and help use the edge of the aluminum to get the center point. Scratch and mark it in, and then rotate it and do the other side. Alright, so there we got our marks on our aluminum block 1, 2, and 3. So what we're going to do is take our spring-loaded punch and go ahead and make indentions, ensuring that we get the center where the scratch marks intersect. There's 1, 2, 3. So if you can see, they're a little bit more indentions of where they intersect. And then from this point we can go ahead and get our drill press set up and then start getting on and getting the starter holes drilled in, and then through the process to get the screw holes tapped and threaded. So first thing we're going to do with the drill press is utilize the ground center drill. So we're going to get it inside of the chuck. This is all this is going to do is be a starter, and then we'll move on to the jobber bits. Place the block inside the vise, tighten it down. Make sure you're using soft jaws when you do this. And then what we'll do is raise that up. Make sure it's center. Just enough to get a starting hole there. Lock it in, and then now I'm using a milling vise with the Y and X axis. I can actually move and make sure I'm going to be on center. Alright, so we got this first one here, so we'll go ahead and start the drill press up and do the first hole. So when you're doing with the aluminum and the metal bit, we're just going to add a little bit of machinist lubricant. Alright, we're going to bring this out, grab a paper towel, check our starter hole to make sure we got a good starter hole, which we do. It's right in the right mark. So we're going to go ahead and go to the other end. Oops, a little too far. Alright, a little cutting fluid. Alright, make sure it stops. Bring this back, let's check our hole. Paper towel, you can also use air. Kind of clean the holes out. Alright, we'll get our next starter hole started. Should be enough fluid on the bit now. Alright, right in the dimple. Nice and slow. Now let's bring this out. Turn that off. So now what we're going to need to do is lower this back down and change out the bits, and then get ready to start running our pilot holes or other tools and start making it large enough to put the fasteners in. Alright, so now I just switched out the bits in the chuck. I'm going to go ahead and use the 5/64 jobber bit. And we're going to start doing the pilot hole, and then we'll jump up to our number 31 jobber bit, and then after that we'll move to threading. So again, I've already preset my drill press for the distance I want to go down, because I don't want to go all the way through. Let's use a little bit of lubricant. Slow motion going down. Check our hole. good cut. Any excess and blow that out. Alright, we'll move to the next one. And then the last hole. That cleaned off. Pull this out, we'll change our bits to our number 31 jobber bit, and then once we get that hole drilled out, we can go ahead and start tapping these holes so we can insert our fasteners. Alright, so we're going to use the number 31 jobber bit and get our final hole. We're going to put a little oil inside to lubricate the bit. Let's put a little bit on the bit. Good measure. Alright. Alright, so now we've got our final holes done. You can get ready to start tapping. That's the finished product once we get done. And then we'll move back over to the bench and start tapping these holes out for threads. Alright, so now we're going to take the 6/48 tap, put a little metal lubricant in here. It'll help kind of get the tap in. Make sure that we stay straight up and down. Get the tap started in. A little bit of pressure. You want to go probably about 3 to 4 turns and then back up to kind of clean some of the burrs up, and then keep going down. You should feel a little resistance, and that's just the tap is actually cutting into the aluminum and making the threads for the Phillister screws to fit into. Okay, we've just hit bottom, so we'll just slowly bring it out and get the burrs off. Alright, there we go. We're going to blow excess spurs out. And then we'll grab a Phillister screw just to see make sure the threads are in there and they'll go in. Should be able to screw it in hand tight, which it does go in. Alright. And we'll back it out. I'll go ahead and knock out these other 2 holes, and then we'll get into removing damaged Phillister screws or fasteners, and probably what you'll see come into the gunsmith shop. Alright, so we got them all the holes threaded, all the screws fit. So what we're going to go do now is take these Phillister screws and we're going to damage purposefully on something areas that you may see in the gunsmith shop that customers will bring to you. So 9 times out of 10 you might have some customers that come in because they try to do a job on their own with using the improper tools or not knowing the knowledge they need to do to be able to take off the Phillister screws or any type of fasteners that's on their firearm. So what I'm going to demonstrate with is just using a standard regular run-of-the-mill screwdriver, and I'm using an undersized bit to try to remove this Phillister screw or tighten it down, just so I can cause some damage on the slot on the head of the screw. So we want to intentionally booger the screw up. As you can see, it's already starting to get that way because I'm using the improper head of the screw, and then sometimes you'll get some flairage of the slot. Alright, so we'll take a really close look at it. We could probably go a little bit more. Let me change the head on that. There we go. There we go. So what we did, and what you can see, is the slot on the screw is pretty much flared out. It's all got some burrs on it and everything. So what we need to do is use some needle file set and kind of clean this up and try to reform that slot, and then test it with one of the gunsmith screwdrivers to ensure that it's a proper fit, and then being able to remove the screw out of the hole. So I got some needle files. I'm going to go ahead and find one that we can use to kind of clean this slot up. So we see the slot, we got some a burr that's right here on the right hand side. We're just going to go ahead and see if we can clean that off. Switch files. Clean up the edges. You still got a burr, little small burr on the left side. And it's still snagging my glove, so I know that's kind of giving me a sign that there's still burrs. There we go, now it's starting to smooth out. Make sure that cut's still good in the center. Alright, we're going to get in there and take a good look. Alright, feels pretty good. So we're going to go ahead and make sure we have, one, the right size screwdriver that fits the head of the screwdriver. We want to make sure we go to the actual full ends. There's little to zero play within the screwdriver and it fits properly, and remove the screw. Let's get it loosened up. We can get it by hand. Alright, set these aside. Now sometimes you can use a power drill or use your drill press to chalk the screw and run it through on some really fine grit sandpaper. I'm actually using a 240 grit right now, so I can go ahead and polish it all on the top, and then we're going to cold blue it with some Perma Blue liquid gun bluing, and then, or you can also use a polishing in for a rotary tool. But we're going to go ahead, since it's such a small screw, we're just going to go ahead and do it by hand. And this will make sure that a lot of the other burrs will come off. And all I'm using is just a block of wood and the sandpaper and the block of wood to kind of keep it stable when I go through this process. Okay. Now what you can also do, once you get all the original coating off, you can use an acetone to kind of help clean it. But we're going to go ahead, also have the Perma-Suit. I have some degreaser to kind of clear the sand off and everything, and the dust residue off the end of the screw. And that'll give something for the Perma Blue to kind of hold on to when you're cold bluing. Don't need a whole lot, we just kind of clean it off. Alright, we'll dry that up. Alright, go ahead and get in our Perma Blue. Really simple application process. Just utilizing a Q-tip. And I can go ahead and just kind of paint the screw. You'll just start seeing it change its color. air dry that. Put a little bit more. And you can put this application as much as you need to try to get to that color match of what you have before. It just depends on how many coats you want to put on there. And it's just kind of judging it by eye and how thick you want those coats to be on there. As you can see, the head of the screw is starting to turn back to before we had it with that original black color on there. And I'll do a comparison to see how close we are getting to the original. So the one in my left hand here is the one we just repaired, and this one here is one that hasn't been used yet. As you can see, if we wanted to, we could still go a few more coats darker if we wanted to, but then it's all on what the owner wants and what the customer wants and how it looks and presentation. And the biggest part is we're able to repair the screw, get all the burrs and the slot fixed, and it's ready to go. Next one we'll move on to is the cross-threaded screw. Alright, so the next one we're going to do is cross-threading. So what we're going to do is take our second filler screw, and then in the center hole we're going to put it in at an angle and try to screw it down, causing the threads inside to strip out, and then utilizing the tap we'll go ahead and straighten those out to make sure we can get the screw back in straight. So normally sometimes you get customers that will try to eyeball if their screw is straight, alright, or if they're working within a small confinement. And not realizing they're putting cross-threading their screw in at an angle. So if you can see here, that screw really isn't that straight. So what we need to do, once you get this into your shop, go ahead and make sure you use the proper screwdriver if you're able to get it out. Alright, and we'll back the screw out. Alright, when you do that, we want to make sure, to check the threads of the screw itself, just to make sure they didn't get damaged in this process, because sometimes they can, and when you try to reuse it again without rethreading the screw itself, you're going to can probably continue to run into the same problem. So the screw looks really good, and we're going to go ahead, and what we can do is, what I like to do is utilize a small light and check the inside of the threads a little bit to see where a lot of the damage is at, which I can see some when it pushed in at the angle, it kind of smashed the threads over here on the left, or on the side here where my finger is. So we're going to go ahead and run a tap through that, and we'll get that set up really fast. Make sure when you're using your tap bit, and you want to make sure it is in straight, nice and everything, and if you got to loosen up, tighten it back down, go ahead and do so. Alright, so we're straight. Alright, so just pretty much like what we did at the beginning when we threaded all these holes, it's the same kind of process to try to rethread these damaged holes. Alright, so we go ahead, once we do this, make sure our tap is straight up and down, like so. If you have to, use some cutting fluid, but this still has a little bit of cutting fluid left on it. And we're just going to go ahead and screw it down. Nice and straight. Again, with short revolutions, 3 to 4. Back it out to clean up some of those burrs. And then back again. And there we go. Back it out. Clean it up, and then back down. Back it out by 1 to 2. Clean the burrs, and then all the way out till your tool you can feel it bottom out when you start getting major resistance. You don't want to try to continue to force it down, otherwise you cause more damage. Alright, so we bottomed out, we're going to back it out. Alright, set that tool to the side. We're going to take our screw. We're going to just try to screw it in by hand. Make sure it goes in straight up and down, which it does. And then compared to the first time, the hole got repaired. The next one we'll move on is if you have a screw that breaks inside of the third hole. Alright, so for this last fastener screw that we're going to show how to repair is when a screw gets broken off inside of the hole. So very different methods on why you would see this is because people are using the wrong tools to try to get a screw out. So these are some of the things that they may have tried to use to attempt to remove a screw, because they'll resort to a hammer when they just get fed up. So what we're going to do is purposefully, also we're going to break this screw off, and then we're going to take it out. Alright, so we're going to use one of these methods with the vice grip. Another way you can do this is with rotary tool with a cutting blade. But we're just going to go ahead and twist this up a bit, just to get it broken, just like so. Because not every time you're going to get a screw it's going to be a clean break. Alright, so sometimes you may have to, you'll get a rigid, if you're able to see that, a rigid line that you may have to file out. So that's what we're going to do. So we'll go ahead and pull our needle files because we want a flat surface to be able to work on. So we're going to take this, move the broken piece out. So we're going to go ahead and file this down until we get a flat surface. Alright, so we actually have a really good flat surface to run off of. So what we're going to do is just move back to the drill press, because we're going to have to use the 5/64 drill bit and start drilling a pilot hole in here to be able to use our screw extractor. So let's go ahead and move over to the drill press. So we got the aluminum block in with the broken screw up already set up in the drill press. Everything's centered. So what we're going to do is just add a little bit of cutting fluid to everything, so we can make sure that we can get the center of that screw to be able to use the extractor on. So go ahead and get this ready to go. Alright. We don't want to go too far in, we just want to get a good spot so we make sure the extractor will go in. Gotta keep it cleaned up and keeping an eye on it. Let's go down a little further. see how far we are. That should be good enough to run. So we'll go ahead and go back to the bench and use the extractor and get the screw out. Alright, so as you can see, we have the hole with the 5/64 bit that screwed down here as a starter hole for the extractor. So all we got to do now is just make sure the extractor is straight up and down, and then in a reverse screwing motion, because we want to bring that broken screw up and out, we're just going to slowly twist, and as you can see, it's coming out. Almost there. And we're out. And we're able to successfully take out the broken screw out of the aluminum block. So this will actually conclude my project of the Fasteners Lab. And I would like to thank you for watching and observing. Thank you.